Hello friends, welcome to part 9 of this video series. In this video, I will explain about Docker and Kubernetes in a high level. Then we will set up a simple K8 cluster and familiarize with a few commonly used Kubernetes commands. After that, I will explain about the IPAM plugin and its uses. And finally, we will see how it's configured in Kubernetes and verify if it's been set up correctly in Infoblox. So before we get started, even if you're completely new to this Kubernetes and Docker, by watching this video till the end, you should be able to set up a Kubernetes cluster and configure the IPAM plugin. So let's get started. So first thing, what is Docker? Docker is a tool to create, deploy, and run applications by using containers. So what is a container? And even before we get to a container, we need to understand what is a container image. A Docker container image is a lightweight standalone executable package of software that includes everything to run an application. That is the code, the runtime, the libraries, the jar files, etc. So all those things packed together into an image is what we call as a Docker container image. The images, and this once we create an image of a container, these images can be stored in public repositories like Docker Hub, which can be accessible through internet, or in private repositories. So that way, once we create an image, we can just store it into this repository, and then someone else can download that image and then they can create a container out of it. So being said that, a container image becomes a container at runtime. So basically what we are doing is we are just running the container or the container image, and thus it becomes the container. So container uses the system resources of the host in which it's running. The difference between a container and a virtual machine is that it's lightweight. When we say lightweight, when we have a virtual machine running on a hypervisor, then each virtual machine will have its own kernel. Whereas for a container, the kernel, it will not have its own kernel. Instead, it will share or it will use the kernel of the host machine. And the diagram that you see on the right explains or showcases the Docker architecture, in which we have the system resources, which we are calling it as infrastructure. Then we have the host operating system. This could be a Windows or Linux. And then on top of it, we have Docker installed. And then using Docker, we are containerizing each of this application, app A, app B, so that each one of them can exist independently. So that's the whole, that's Docker on a high level. So again, this is just on a high level. So please, if you want to get more information, please visit the Docker website so that you can learn more. Okay, so let's get to Kubernetes. So Kubernetes is used as a container orchestration platform. So what is orchestration? So in simple words, let's say it say it enables the user to automate the process of deploying and scaling containerized applications. Kubernetes has a master-slave architecture. So that means a Kubernetes cluster is comprised of a single, or now the latest versions of Kubernetes are supporting multi-master for redundancy, and then it also contains several slave nodes known as the worker nodes, and it is this worker nodes in which our applications, which is wrapped up, or which is contained in a container, is deployed. Again, when we come to Kubernetes, there is a concept of pods, but yeah, for the time being, let's not go there. And when we do Kubernetes deployment, or when we set up our Kubernetes cluster, I'll just explain the the commonly used concepts and the commands. Okay, so now Kubernetes, what are the advantages of Kubernetes? Kubernetes allows an application which is inside the container, and in the Kubernetes world, every container or is within a pod. So pod is the is the simplest unit in when we talk in the Kubernetes world. So what a pod is, I will explain to it in the later part of the video. But yeah, understand that an application which is inside a container is inside a pod, and this application is deployed on multiple worker nodes, thus ensuring high availability. So even if a worker node goes down, since the application is present in multiple worker nodes, our application will still be accessible. And it also provides functionalities like load balancing. So that's one huge advantage of Kubernetes. Then another advantage of Kubernetes is that it supports functionalities like scale in, scale out on the fly. That is, if let's say you have an application which is deployed in 2 ports, or again, for the time being, think as pod as a wrapper to the container. Okay, so this if that application is being heavily utilized, we can scale out that application by by spinning up a new pod which contains that application. So that way, now the that application can will be accessible without any issues. And also it supports functionalities like self-healing. So what self-healing is that, let's say a pod dies due to some reason, a pod which contains the application dies in one of the hosts, then the Kubernetes has a functionality to recreate that pod by itself. So that's what we call as self-healing. And then one of the major benefits of this containerization is the ability to speed up process of building, testing, and releasing softwares. It supports functionalities like automated rollouts and rollbacks. And then it also supports canary deployment, etc. So what is canary deployment? So it enables the user to test the new deployment in production in parallel to the previous version. Say for example, you have an application, so that application is in let's say it's running version 1.0. so an upgrade is available, and then the application has been upgraded with some new features, and then the version has been upgraded to version 2.0. so even in production, what we can do is the same application, both the versions can be run simultaneously, and so that it can be tested if it's stable and all those things. And if it's stable, then we can scale down the previous deployment and scale up the new deployment, so that the new code or the new application or the updated application is not deployed in production in one go. It's like in staged, it's in stages. Okay, so I hope you got some fair bit of an idea on what is Docker and what is Kubernetes. So now let's get to setting up a simple Kubernetes cluster, and I will walk you through step-by-step process or all the steps. Okay, so for this we are setting up one master and one slave or worker Kubernetes cluster. So these are the high-level steps. The first is we will set up a host name on both the VMs, and then we will install the Docker, and then we will initialize the Kubernetes cluster, and then we will install Flannel, which is called which is a CNI or container network interface. So basically this allows all the pods to communicate to each other. And then then we will see how to join the worker node to the master. So these are the high level steps. So let's get to a lab and let's try this out. Okay, so we have two virtual machines, one known as the Cube Master and the other one called Cube Worker. So first we will set the host names for both the VMs. So I have created a notepad which has all the steps so that we can get this done real quick. So first we set the username to the master, and then let's set up the host name to the worker node. And then these are the important softwares which we would be needing. So let's install that in both the VMs. Then we will install curl. And finally, we will use NetTools, install NetTools, which is, only after this we can issue commands like fconfig. So that's done. So let's now start. First, let's update the database, and after in the Linux in the VMs, and then we will install Docker. Let's install Docker. So Docker is required in both the VMs. And then we will start the Docker. What happened here? It's not able to resolve. Okay, so now Docker is installed in both the machines. And finally, let's enable Docker. Okay, so now that's done. So now let's download a package which which we would need. First, let's add the key, which will with which we will be able to add a repository for installing Kubernetes, and then we'll continue the installation process. So first, let's add the key. And again, it's required on both the master and the worker. So now let's add the repository. Let's try that again. Okay, so that's done. So seems like I'm having some issues with the internet connectivity. Okay, so we have added the repository. So now let's add the KubeADM. Again, KubeADM must be installed on both the master as well as in the worker node. So once the KubeADM is installed, before we do a KubeADM init, that's where we are initializing our Kubernetes master. We will have to issue this command. Okay. So basically we are disabling the swap. Okay, so now we are good to do an initialization. Okay, so this port network, so we can actually give any network over here, but there is a reason I'm giving this very particular network during this KubeADM initialization, because after this we are going to install a CNI called Flannel, which will provide the networking to our Kubernetes cluster. So that Flannel by default has this network as default. So if I have to make a change now, I'll have to again make a change on the Flannel configuration. So just to eliminate one step, I'm going with the network which is by default configured in the Flannel. So this init should be performed only on the master. So now what it's doing is it will download a bunch of images, Docker images, and it will spin up the necessary pods that is required for the working of Kubernetes. So this is happening in the backend, and after this is complete, we would see a screen that the initialization has been completed. So we'll wait for like a couple of minutes. Okay, so the initialization has been complete, and it instructs us to issue these commands. so that we can run Kubernetes as a regular user. That means as a non-root user. And also it also tells us that now we need to deploy a port network, and that network is nothing but our CNI, which I was talking about before, called the flannel, and that we will be installing. And once that has been set up, this is how we can join our worker node. So first let's take one piece at a time. So let's issue these commands. Okay, so now let me create this folder, and then let me copy this contents. Okay, so now let's run our first Kubernetes commands, that is kubectl get nodes. So that will show us how many nodes this my Kubernetes cluster is having. So right now I have just the kube master, and the status is showing as not ready. And I will tell you why the status is not showing as not ready, because one of the pod is not running. So to find out that, we have to run kubectl. What did I make? So this is the command, and as you can see, the two core DNS pods are showing as pending, and the reason is that it's not having an IP address. So in Kubernetes, whatever you are seeing here is actually, it's not a port network. Instead it's the IP address of the host itself. So if I do a IP config, we will see that the IP address of the master is 192.168.0.39. So in order to have some sort of a port networking, I need to install a CNI. That CNI is what I was referring to as flannel. So let's install the CNI. Okay, so installing the CNI, this is the command. So we will download the YAML, which describes the flannel, which has a flannel configuration, and it will also download the image, the the flannel pod image from the Docker Hub. So let's run this command. Okay, so now if we do get, so we could see that another pod is running, and that's the flannel, and now it should be able to provide IP address to my core DNS ports. Okay, so now it got the IP address, but it's not ready. So I do it again. Okay, so now all the ports are running. So now let me check the issue the kubectl get nodes command, and as you can see, now the status of the kube master is showing as ready. So now we are good to join my worker node to this cluster, and to do that we will use this command, which has been generated after we successfully completed the barium initialization. So we'll just copy this, and we will, from the worker node, we will just paste it over here. Okay, so we got a message that this node has been joined to the cluster. So what we can do is we can come to our master and issue the same command, kubectl get nodes. So now it's showing as not ready, but it should show up ready shortly. So let's see if all the ports has been configured. Okay, so now everything is running, so we should be able to see okay, so now my Kubernetes cluster is up with one master and one worker. So now we will be able to use this Kubernetes cluster to and use the IPAM plugin and configure the IPAM plugin and verify if it's working fine from Infoblox. So I'll come to that, but let's first see what is the what do you mean by the IPAM plugin. So coming back to our slide, so whatever steps that we are seeing in Highlevel, that's the exact so all those steps has been executed in the VMs. And if you just take, if you pause the video and look into the notepad from which I copied all the other commands, that would give you a fair idea of what I have done and what are the commands which I have issued to get it done, to bring my Kubernetes cluster up and running with one master and one slave worker node. Okay, so now let's understand what this Infoblox IPAM plugin is. The Infoblox IPAM plugin for Kubernetes is a managed plugin that interfaces with Infoblox to provide IP address management services for the pods in Kubernetes. So if you remember, when we issued the command kubectl get pods, so it returned a bunch of pods, and I told you like the core DNS, so that needed one pod network for it to come up. So for the pod network, what we have used is a CNI called Flannel. So Infoblox IPAM plugin is also providing similar capabilities, but if we directly install the IPAM plugin without installing Flannel, it was not working. So that's why I have to install this Flannel first, and then on top of that I will install this IPAM plugin, and that should complete the configuration. And also this IPAM plugin is one thing, and it also consists of a daemon which actually runs as a pod in Kubernetes, in our Kubernetes cluster, and this daemon talks to the grid master through REST APIs, which updates the IP and the network views that is being in Infoblox. So basically all the IPs that is being used up when a pod is being created, that IP address will be updated now in Infoblox, and a separate view, network view, will be created in Infoblox, and the IPs will be, and the network and the IPs will be updated inside that new network view that gets created in Infoblox. And all these things happens through a REST API call. And yeah, one important thing which which gave me a lot of trouble is that when I tried doing this, initially it was failing. So when I tried troubleshooting it, what I figured out was that a license was required. So this cloud network automation license is a prerequisite for using the Infoblox IPAM plugin. Without that, it will not work. Okay, so I hope you got a high level idea of what this Infoblox IPAM plugin is. So now let's try and set it up. Okay, so first we will, and also this is a open source project, so the code is available in the GitHub, and that's what we are cloning. So let's, and this, let me copy and paste it over here. Okay, so I think it's okay, so that's got created. So now let me tell you what are the files that we need to update so that it can talk to my Infoblox Grid master. Okay, so before that, let me show you my grid. So my grid's IP address is 192.168.0.65. So let me log in. And let me go to the administration network views. So currently, okay, so I hope you are familiar with this network views. So network view is nothing but a network space. So the advantage of having network views is that you will be able to have overlapping networks, let's say in both the views, or that's the whole advantage of using a network view. For example, if you have a 10.10.10.0/24 network in the default view, you can have the same network in a different network view. Whereas if you're using only a single view, then you will not be able to do that, because that's if you're using two separate networks, that will result in overlapping IP address space, right? So just to segregate to IP address space, we have this concept of network views in Infoblox. Okay, so currently we have only one network view. So basically that's what I wanted to show you. So let's get back to. Okay, so as I told you before, so there are two things. One is the daemon and the other one is the plugin. So the daemon is responsible for talking to the Infoblox Grid master. So let's see what this daemon contains, or the daemon .yaml contains. So go to CDK8. Okay, so we will edit the daemon first. Okay, so for this daemon, the important arguments that you have to modify is this, the grid host, which should contain the grid master's IP address. So that is 0.65 in my environment, in my lab environment. And then the WAPI port, that is the RESTful interface port, is 443, and the username is admin. And all these things you can keep it as default, you don't have to change. And instead of providing our password, so what we are doing is we are providing we are decoding our password into a base 64 encoded format. So whatever we are seeing here is not our password. So this, if we convert this or decode this into a clear text, this will be Infoblox. So I'll show you what I'm saying. So basically whatever you're seeing, this string is in a base 64 encoded format. So okay, so now let me decode that string. So this was a string. So if I do a decode, so the decoded value is Infoblox. So if you're, in my case, I'm using a default, I haven't changed the password, I'm still using admin Infoblox. But in your case, if you are using a different password, then you have to come to the site and click on encode, and whatever password that you are using, you have to type it or paste it over here, and then encode it, get the encoded value, and then paste it over here. So for example, if I'm using Infoblox 123, then I have to encode this. So it will give, so this is the corresponding base 64 encoded format, and this is what I should copy and use it in the WAPI password. But for the time being, I'm keeping it as it is because I'm using the default Infoblox password. So in here, that's the only change. I just changed the grid host. So that's all I need to do. So now let me save this, and we will also edit this file. So this file contains the configuration of the plugin itself. Okay, so in here we need to modify three things. The first is this interface. So this interface name should be interface name of the master. But the reason I'm logging into worker is because the interface, because since both the machines are Ubuntu machines, the name would be same. So in this, for both my interfaces across both the virtual machines, since I'm running the same Ubuntu operating system. So that's why I didn't want to close this file and then get the interface name. So that's why I checked in the worker, but what you should be providing is the interface name of the cube master itself. And then this is where you have to change, because if you remember when we did a initialization, so let me pull. So if during initialization we gave this as our port network, so we have to use the same network over here. So let me update this one. And let me set the gateway as well. Okay, so this network view, whatever we are defining it over here, so that's the view that's going to be created in Infoblox. So let me say Mahesh underscore CNI underscore view. Okay, so yeah, so these are the, so again, this network view is optional. I just gave a name, unique name, and the important things that you have to change is the master, which should contain the master's H0's interface name, and then the subnet which you have used while during initialization of your Kubernetes, and the gateway. Okay, so after doing that, let's save this file, and now let's deploy these two YAMLs. So to deploy, this is the command. kubectl create -f and the YAMLs file name. Since I'm in the folder itself, so I can just go ahead and give this. So now it's saying that a daemon set called CNI Infoblox daemon is created. So what daemon set is it's actually a type of deployment, I can say, in which the pod that it will create a pod in all the nodes. So rather than we defining a specific number, what it will do is, let's say if we have hundreds of worker nodes, it will the daemon set will create a pod in each of these 100 worker nodes. So even if we are, in future we are adding a new worker node, this will ensure that a pod gets created in the new worker node as well. So let's see if the pod got created. So let's copy the command kubectl get pods. Okay, so if you see here, another pod got created and it's ready and it's running state, and it also picked up an IP address. So this IP address is actually the node IP address itself. So we will also deploy the other the CNI Infoblox plugin as well, because this was the daemon. So the command is the same, that is kubectl create -f, then this YAML file. So it is again creating another daemon set, but as I said, daemon set creates a pod in each of the nodes. So let's see. Okay, so now the plugin is also running. So now what we have done is we have created the CNI, or we have configured the CNI plugin and the CNI daemon. But since we have already configured what do you say, CNI, that is CNI is the container network interface called flannel before, we need to modify the configuration of that flannel, so that, because right now there are two CNIs, one the Infoblox plugin and the other one is the flannel which we have configured earlier. The reason why I had to configure flannel is because if when I directly configured just this Infoblox plugin, it wasn't working. So this is how I have to come up with a workaround. But yeah, if anybody has we're able to successfully use just the Infoblox plugin without using any other CNI, then please let me know so that I can also learn. But yeah, this is the way I tried to make it work, because the documentation that is available in the Infoblox site, first of all, it's very old, like it's almost an year old. So the Kubernetes version that is being used in there is old, and right now we are using the latest Kubernetes version. And also it's really kind of confusing for me. So yeah, but if somebody has successfully used that guide and deployed it without using any additional, when I say deployed in the latest Kubernetes version without adding any CNI, let me know. Okay, so coming back, so I was talking about changing the configuration. So for changing the configuration, so we need to go to a worker node, and we need to go to cd etc CNI folder, go to net. Okay, so if you see here, we have the flannel configuration file as well as the Infoblox IPAM configuration file. So how this, if we have multiple CNIs, how Kubernetes takes this, it will check which comes, which has it will take in the alphabetical order. So numbers getting higher precedence than the alphabets. So now we have this flannel which starts with 10. So obviously this flannel CNI is going to be always taken by Kubernetes. So what we're going to do is we're going to rename that to something which will start with Z. So this way, since infoblox.ipam.conf will have a higher precedence over Z flannel, because now it starts with Z. Okay, so now if I do a ls, I could see that my flannel's configuration file has been renamed with Z, so that means it will not take precedence. So now what we're going to do is we're going to do a test deployment and see if in my Infoblox a corresponding a network view, as well as the network which the pod network that we are using in Kubernetes got created in Infoblox. So first let's do a test deployment. So the folder which we have downloaded itself has a an example folder, and it has a test app.yaml. So basically this is a test deployment. So we can kubectl create f test app.yaml. Okay, so now we could see that a deployment has been created. So let's check our ports. Since I've taken remote of this, it's really slow. Get ports, okay. Okay, so what we saw is that it has picked up an IP address. So now we will go and look into our Infoblox and see if it has been updated successfully. So we'll go to so first we will go to administration, network view, and as you can see, a new network view has been created, the same name. And now if we go to data management, and we will see an option to choose between our two network views. So if I select the Mahesh CNI view, I could see that this network 10.244.0.0, which was our port network, has been created over here. And if I go to the list view, it has already updated the two, that is 10.244.0.2 and 10.244.0.3, which are the ports that was created as part of the test deployment. So this way we can verify that the CNI plugin or the IPAM plugin has been successfully set up in Kubernetes and Infoblox. Also, if we go to our logs, audit logs, then we could see that the U type is API. See, we are getting the API calls, or we are. So if you see via API means it's an API call. So a login has been attempted via an API, and it created a network view, and yeah. So and it also updated the two IP addresses, which was the IP address of the two ports that we just created. So that's it. So let me get back to my slide. Okay, so let's have a quick summary of what we have learned today. So first we went through what Docker and Kubernetes is on a high level. Then we went step by step on how to set up a simple Kubernetes cluster. But again, there was some issue with my internet connection, because of which there was some delay. But yeah, hopefully you guys can understand and you can just skip whatever portions which took time. But yeah, take just pause on this on the notepad, which contains all the commands which you can just use and try your own Kubernetes, creating your own Kubernetes cluster in your home lab or in your environment. Okay, so then we looked into what Infoblox plugin is, and what are the uses of the Infoblox IPAM plugin. And finally, we set up the Infoblox, again, step by step, we set up the Infoblox IPAM plugin in Kubernetes, and we also verified that that IPAM plugin is able to talk to my Infoblox Grid master, and the IP addresses are getting updated in my Infoblox Grid. So that's it for this video. Hope you found this video informative, and I will catch you up on the next video. Thank you.